And we'll have one extra guest on our panel today, Stephen James. Stephen, you want to give a quick intro to serve Windows and Mark?
Sure.
Yeah, hey everyone. Yeah, I'm Stephen. I did my PhD at Imperial College London and Tompson. I'm now finishing up my postdoc with Peter Beale, Berkeley, and I'll be moving into my new role as head of robotics at ICRA. I'll be working on robotics.
Thank you. What are you guys like for this? All right, we'll kick it off with some questions from online. The first question here, I believe, is probably for Nicolai, but anyone can really chime in. Would you say designing the experiment before conducting is similar to test-driven development in industry? If not, why and how? So, take it.
Yeah, so that's a really good question. So thanks for that. There's a lot of similarities, I guess, between those, right? So it's all about thinking about what is it actually you're trying to achieve, and then sticking to it. And especially for this publishing of the negative results, I think that it is really important that we are honest with ourselves about, okay, so our hypothesis really, we didn't validate that. We made something that really didn't solve the problem. And then be honest about that, so we can discard it quickly, but potentially do a paper about it and then show everybody else that this is not the route to take, and then continue on. Yeah. Do you have any insights you want to share? You want?
Maybe I can add to this, or not add, but rather ask a question like, what is the right way to also to share this experience that you made? I think it's extremely valuable for everyone in here, and I think in the research community, we do it, but we don't do it enough. We talk a lot about things that work, but not about the things that don't work. There's very few workshops where it's actually the topic, and there's no honest exchange. And it's getting worse and worse the more you move to the industry, just because they have to be protected to a certain extent. And that also makes us replicating a lot of stuff unnecessarily, just because we are just as stupid as our neighbors. So how can we improve that?
That's it's an awesome topic. I got my in Danish it's called ildo, it's a fire baptist. So at my master's degree, I did a whole year study about how to learn local features in 3D. And we failed miserably. I used a whole year just to accuracy curves to say zeros. We learned enough about that. So but it still became a really good thesis at the end. And I guess that's also why we should would have primed me in going in that direction. So it's also about, I think it's also very much a cultural thing. And now I'm Danish, so that's speaking from my perspective, about how we deal with failures and how we feel about, is it a failure or is it not a failure? Because I can recall the feelings I had about going to my defense with results that were, oh, this is not working. But the thing to finish the story with that is that I obviously got my degree. I also got my degree with the highest honors, so that's just to showcase that it can be done, even with results that doesn't work. But still, the feeling about going into that room was terrifying, because you were not as lucky as your neighbor that made something work. And still, for me, it's something that I'm working with personally as well, and our whole organization is working with it, especially in this being honest and transparent about, okay, so we did this, it works like shit. We don't want to go this route. Go somewhere else and play. This is not it. Yeah, feel fast.
How would you guys think about reviewing a submission of a negative result? I think that there's some challenges there, especially because most of what we're doing can be well characterized as engineering. that people could read a paper like that and say, well, I wouldn't have made that decision, so like this negative result is basically not that relevant for what I want to do, right? So it seems like there needs to be some norms and rigor around even like preparing a negative result submission that would have any impact.
I like to just point out here that there is an appendix, right? And it's not common at all, but there have been some organizations that start putting in what we did and it didn't work. And you don't get much credit from the conference itself, but you get a lot of street credit, I think, because people who are attending the conference will talk about it a lot. And I think Google actually have started mentioning this. I've seen it in one particular account before. And yeah, it may not increase the chance they get accepted, but every time I do talk to someone about that, they actually end up talking about things that I didn't work. And I think it's great. I think we should be doing more of that.
So I want to, yes, I want to pull this a little more. This is a question follow up to all of this, mostly for John because he works at Google. And so I remember from my time at Google, the culture was very much on doing when something went wrong, when something you didn't work, when something blew up, you do the post-mortem to figure out what went wrong and what you can learn from it. And I know, like at my current company, we do the same thing, and it's common in other tech companies as well. Is there something from this idea of doing a post-mortem that we could bring into academic research?
Yeah, I think it's hard to keep the culture of the blameless post-mortem. It's very easy to fall into traps of sort of trying to explain away why someone tried an idea and maybe push it on you that didn't work. But when you get there, I think you focus on the results. I think that helps. You focus on how you would avoid these sorts of things in the future. And in research, you can sidestep entire years of research if you just know that an idea won't pan out. So I think as long as you can communicate that these negative results are useful for everyone, I think they might become more popular. It's a very negative conversation, but I think we do see some light at the end of the tunnel, right? Like I think Lynnerup has every year a reproducibility challenge. There is like really good benchmarks coming out. I think things are getting better. But yes, it's still true that I guess people don't publish negative results too often, or if they do, actually, I won't call out the authors, but I had one of my papers, one of these rethinking such and such algorithm, and yeah, these are tough to review, right? Especially as someone who wrote the original paper. There's a lot of emotion invested in these things.
So hypothetical situation, maybe not that hypothetical. I just read a really cool paper. I went and I downloaded their code and I downloaded their data set and I tried it out on their data set and everything works as expected. And then I switched to my data set, nothing works. What do I do next? Discuss.
You email the first author and ask questions.
So maybe a little more concrete. What do you guys think is the right procedure for actually trying to convert an academic project into a real world scenario?
Let's just take this up.
So I'm not sure that there is this magic one procedure that could ensure that we could do that. I've tried a lot of different ways, and during my PhD, the result of my thesis was a mere conclusion with a set of guidelines that you could follow through, but there's no one size fits all here, which is also one of the inherent problems of reproducibility. Right? So, and it quickly becomes like a negative talk, and I try to, with the memes, and do it like a fun thing instead of that, because we need to be honest with ourselves. So what I did with these, I have four different industrial cases with my PhD, was that I tried to adhere as much as I could to the original works. But there is just, as you also mentioned, that there's these times where you just get caught up in, now we just want to try and fix this. We will pursue this until the end of the road. And that's very hard to get out of that. Specifically for the dependency hill, I have used so many months trying to get things to compile before throwing the towel in the ring and saying, okay, no more. Now I'll just try to implement the idea myself and then see how it works. So I'm not sure if there's this one way to do it.
Maybe to put a slightly different spin on this, I think what you're describing is actually not that unreasonable. Like different data sets are hard for different reasons. And I feel like what happens in academia is we like pick one domain and we sort of like overfit to that at the algorithm level. And so like, I don't think it's that surprising that you try it on something completely different and it doesn't work. I think that's just a sign that we should like try out some new ideas or like have a new benchmark.
If I can add to this, I mean, one problem is also that these data sets are not available for academia, right? So we have also a problem that we collect very useful data from our clients and customers, but then they don't want to let us share the data with others. So that's one problem of the industry. Because, I don't know, maybe we see it differently in this automation in warehouses, but in industrial processes, it's always like that. So, but we get actually quite good, good experience with, testing work from academia and providing feedback. So people are typically interested where does the algorithm fail and learn from that. But then it's really sad we cannot share the data set.
Hey, maybe I could throw maybe a slightly counter argument. I wonder if we're in danger of bringing academia too much into the rise of one applied set. And actually, there's an agreement we made somewhere with who does the applied stuff in terms of we don't want to bring all of academia to the next table. But we want to talk about 15 minutes, right? And if we ignore that, there's a danger that we're essentially just becoming the extended one of the industry. I think this is a philosophical discussion to be had about who's responsible for what, and that needs to be everyone at the same. So I wonder if there was feeling for that.
Yeah, I have surprisingly strong opinions about this. I think that's true, though academia has gotten stuck. Like benchmarks like the Majoku suite of Half Cheater and Hopper or whatever, they've been pretty useful, right? But I think we did get stuck a little bit over optimizing 14K, 15K on Half Cheater, which is not particularly useful. So it is nice, I think, for at least someone in on the research side to sometimes try real world problems just to make sure we're on the right track. But yeah, I guess there is a balance to be made.
I think maybe the other thing that's tricky about robotics compared to other domains is like you can't get someone else's robot. And I just don't know if there's an answer to that.
All right, we'll do another question from online. I think this is for the keynote, taking this in a very different direction. Is there a related publication or data set available for the object detection and cluttered scenes mentioned here? I assume here.
There's not anything though. Sorry, I don't think there's anything released.
Could you release one?
We've been talking about it actually, so maybe it will happen. We also have this problem that like our customers don't want us to like share their images. Like they don't even want us to like put it in slides like this. So it's going to be tricky.
Very Seamus, but one of our papers, we do have a public data set for cluttered scenes from Kentaro, myself, and Andrew. So yeah, I've got Kentaro myself and
Question. So I've been seeing this eclectic circulating a bit, but some people have been saying, at robotics conferences, all results should be demonstrated on real robots, like without fail. I wonder what you think about that, whether that, it's a lot of work, obviously, for some kind of projects are more theoretical, etc. But like, what do you really think about that? Whether that would be like a negative or positive? Would it be too slow? Like.
So I can start off with this. So your question was if all research should be done on real world robotics and not simulation?
Sure.
Yeah. I did all of my work on real world robotics, so I'm obviously biased in that direction. The reason I did that was because it was too time consuming for me personally to learn the simulation framework, set it up and do my testing there. It was just too far away from what the company wanted as well. We had a few initiatives like simultaneously with my PhD doing that, and we had some nice results out of it, but it's just a lot of work for at least for us more closely to the industry. But I don't think that every researcher should do it on real robotics. I think it's at least as important to do it in simulation as well. As you said, it could be more theoretical approaches and stuff that you want to be able to scale up to 100 or 1,000 robots, and especially in cases where we cannot collect that data from our customers, then we need to be able to create that or augment that data ourselves. Right?
Yeah, just before I answer the question, I've actually never heard someone say that didn't want to spend time on a sim because it would take too long. Normally it's always the other way around. Anyway, yeah, I think the robot learning community actually has this pretty well right now. So what you tend to see is like 90% of the experiments done in sim for like the robust analysis, and then there's normally kind of a section at the end where they kind of try and get this thing to work on the real world. For me, I think that's quite a nice compromise because you can't do like robust evaluation really in the real world. So it's nice to see like how it actually performs, and like hopefully everyone uses like the same simulated environments as well. That's important. But then show that, hey, look, if we did want this to work in the real world, then hey, it does actually work. So yeah, I guess I'm in the camp of, you can spend 99% of the time and say that's fine, but I think it's really beneficial to show that it does actually work in the real world. Another thing I would add is actually depends on what you care about. If you don't care so much about sample efficiency, then it's less of a motive. But I actually think that if you care a lot and you want it to be like trainable in say a few hours, then probably staying away from sim is a really good idea because it keeps you kind of on task. Because if you're not gonna be willing to stand there for several hours, then it's not really sample efficient.
Something we've seen is that actually, like once you're in the long tail, doing real world evaluation gets kind of hard. Like if you have some failure that happens like 0.1% of the time, now you need to run your robot for like 3 hours to have it happen one time. And then if you want to be like more like robust with like hypothesis testing and like that, now you're talking about like days of like, or like robot days of like running the experiment.
Another question online, also for Nikhil. To covariant, for new object segmentation, the network might make wrong segmentation. The network still outputs masks with high confidence. How do you deal with this kind of situation in an online environment?
I guess I guess this is like a feature of most machine learning systems that they tend to be confident. And I would say like I don't know if we really have an answer to that. Like we've sort of done some work in this space, but nothing like too convincing.
So since most of you are in a management position in your company, like I was wondering in general, when you start your company, like from like your academic research, like does the research like continue to move on? Like when you develop your company product, or how does that process work? And like while you develop your like product in the company, how do you manage or develop your like research asset in your company? Yeah, I'm not as interested in first of all, I think Professor Cooper might be.
I think it's a very, very dangerous situation for startups that they keep going as they were doing before, and then you get stuck in interesting research, but you don't understand the market, the customer, and to make a product that eventually makes money. There's some company that can do this or could do this for a very long time, but there's very few that get permanently fueled by new money to continue like this. I think it's important at the same time to keep some sort of a balance. I think that's where also the exchange in academia has to remain very, very close. Because typically you're not making a jump out of academia and you connect or disconnect yourself completely. I think it's important that this dialogue stays, that we have here a very, very close interaction between the industry and academia, because this is also the industry that like is kind of profiting most from us, and we profit also most from them, because they bring us some exciting problems that eventually like create a lot of new exciting research problems on our end. So I think that is just like one of the mechanisms that helps continue this both as successful on the research side, but also on the product and let's say the business side.
So at UR, we also try to continue the collaboration with the university that we are close to. And we also like try to expand that collaboration with other universities. Obviously, when you're very close to someone in physical distance, then it's easier to have meetings and have projects together. And I think that this is where some of the most interesting innovation happens, is where we provide some use cases from potentially some of our customers to the academic world, and then they try to spin off some interesting technological advance to solve that issue. I think that's a very good way to finish that feedback loop. But it is hard to do that because we have a lot of stakeholders with different objectives, right? You have a customer that wants a solution, you have academics that wants to publish their work, and then you have a company in the middle that tries to patent everything and keep it closed. So, so it is a tricky process, but up until this point, I think we've managed it pretty well as well. So yeah.
I was just going to add to that. I mean, robotics at Google is inherently a research group, so we don't really have this problem to some extent. So a slightly different take, though, I think is it's really easy to fall into a trap of working on some subfield and not maintaining a diverse set of research topics. And I think I'm at any given moment I'll tell you what I like, and if you buy me a beer, I'll tell you what I don't like. But if you do it for long enough, you realize you're often wrong. So maintaining a set of projects that will maybe some will pan out, some won't, I think is super important. And that's true for research and sort of production problems. So
I have a question about robot learning if you wasn't talking about it. So a lot of times we talk about generalist agents and how you want robots to have these very general set of skills that are applicable in the world. But I also feel like you don't give the robot enough time to actually learn something. Like, my patience is limited, I'll give it a day and it has to learn this. Are we just limiting ourselves with being something short term of being impatient, with not giving any agents enough time to learn something? Are methods there that if you give it enough time, you can actually learn something useful? Or how do you cover this, especially when you have deadlines and deployment schedules?
I mean, I think if you're going to get to 100% success, you wait for it. But yeah, I think that's a research problem, right? Like if I have a task where I have to wait multiple weeks for it to do well, can I then deploy that policy on something else? It's totally a research problem. Lots of people working on it. I don't know if that answers your question there. Yeah, I think it depends on the task, and it depends on the production application too on that side. Like maybe my business model is like Gehring or something, where I'm collecting training data, and it's okay to collect a week if I can then deploy for a year. Sorry, I don't mean to speak on that. But we have similar problems where for some things we want to be able to adapt very quickly, and so you need certain algorithms there. And for some things, it's okay to pre-train for a month, and that's also okay.
You talked a little bit about computational pipelines for autonomy. I was wondering what are the consequences of that the failure analysis. So for example, you encounter a new failure and there are like different blocks in the pipeline. Which block to assign that failure and which block you should take off to improve the system? What does that process look like at Google?
Yeah, I don't know if there's like a one size fits all solution because it sort of depends on like what are the like blocks in your pipeline and like what are the tasks that you're solving. But I think it's a lot of it is like just having good tooling and good infrastructure.
So one thing I'm sure you all don't have is a lack of customer problems you could be working on. So the question is, how do you sort of pare it down to the ones you're actually going to work on the next year?
So during the last year, as I mentioned a couple of times, UR has made a large transition because we also had that issue. We tried for many years to build a robot that generalizes well to every issue that the customer could be working on, be it palletizing or be it surgical, almost. Obviously, we don't do surgery. But we have taken another strategy, which is to boil down into specific market segments. So right now we're looking into welding. We have a huge opportunity there from a business side. And we also have that within palletizing and cheese handling. So those three areas are the things that we focus on there. Then we spin out and try to talk to some customers, find out what is their actual pain points. And then do this lean startup approach where you write up all your assumptions. So we assume that that cleaning is an important part of machine handling. We don't even actually know, but we will go out and talk to customers. Okay, we find out. So for aluminum parts, it's really important to clean while it's also. Okay, fair enough. Then we know that. Then we can try and develop some prototype for addressing that specific issue. So that's the process that we follow, at least to prioritize. But it is sometimes we call it dumping because we feel that it is a lot of time spent on choosing the right things. But that's the important part, is that we actually then choosing the right things instead of building features across a whole year and then releasing them and nobody using them because it's useless.
Yeah, at the robotics, we basically it's a full process, right? It's not a single person can manage and figure out what are the priorities with a kind of roadmap to the process with different stakeholders from engineers that know there's a supply chain issue we should solve, or that's something we could do much better in the future. And then you have all the reports from the field, from customers that want to have this and that, and that thing should be in green color. And but we try to put this as a cost and benefit tag to each of these features and weight them accordingly and prioritize.
Can we hear from all, or?
I have questions. So, the topic is about applying activities. So, what are the processes? What are you looking for in that research when you're making decisions on what to try out or which directions to go in? And is there anything that you can share to that community? Provide this information. Or maybe be a little more provocative. What are the red flags?
No code. So one of the things that I at least use a lot is code. So even if it's not like executable, you can't install the dependencies for whatever reasons. There's just something about code that can tell you a lot about the method that's hard to put in writing. There's a reason why in IP that code is copyrighted, right? It's an art. There's just some little finicky things that would be pretty hard to explain, but it's very obvious to see in code. So that's one of the main things that I use when I evaluate if this is an approach that we want to address.
I guess it's very different depending on the type of company you are. If you're at Google, you might look for something that is exciting but can have another 10 years of investment. When you're a startup, you want to have something that in reasonable time, reasonable effort makes a huge impact on your side. You can't afford to just jump on something and then invest another 10 years.
I feel like there's a bit of an art to like reading a paper and looking for red flags. And I think it's mostly along the lines of like, if it worked as well as they claimed, then they would have done this other experiment. Or like, it's sort of like by omission, it tells you that something's like kind of fishy.
Yeah, I mean, I think like lack of baselines and like good ablation studies is like a bit of an art. And it's somewhat on the academic advisors to make sure that like we're doing our due diligence to actually test things properly. It's certainly something that I look for. But even then, you can, the community can agree on an approach that we all think is right. And still, there's something about their evaluation protocol that made it better than everything else that doesn't actually matter. So, things get missed, even on really great papers that are really great experiments.
I also think there's probably not a huge incentive to do a huge sweep, right? Because you, as a PhD student, you're trying to get as much output in your 3 to 4 years, so you're going to essentially do the minimum required to get into a conference, right? So maybe that's kind of culture change as well. Perhaps trying to do some kind of publish or perish sort of culture. And related to the question, actually interested, because obviously this workshop is about applying to the real world. So I'm interested to hear a panel as well, like applied research. I'm personally not a fan of that term because it implies that you just take methods from academia and apply them to the system, whereas I see it as you're trying to build a product for whatever means necessary, whether that means applied research or, in my case, which is applying to household robotics, you can't apply research because nothing works. So you have to do your own research. So I'm just interested in that sense like that.
I mean, I can tell you my view. I love to do things which you would call as applied, but that means we're going to do things that are running on a robot because that's my honest belief that we learn so much if we go on the real system. And this opens up many, many new topics that we may want to start a new research about it. If you don't do this step, if you stay in pure theory, pure simulation, we do not encounter these things. And that might stay in purely theoretical and nice, and you can make a nice paper of it, but you don't make the next step. So I think having some sort of applied part in parts of your research is very important. I strongly support in all labs.
But just to clarify, do you define applied as? It seems like you're defining applied as getting something to work on hardware, right? Because that's my impression, my opening answer. Whereas I guess I'm saying that I feel like a lot of people just assume applied as like just taking off the shelf and just like trying to run it on something. I think that's very different to like just getting something to work on a product through whatever is necessary. I kind of see that also as kind of, is that the same as applied?
Yeah, you're absolutely right. There's still a process from research being published into a product. Right? There's a lot of maturing there. There's a lot of quality assurance that we need to make sure that these new methods actually fit into that and go through those gates. So just recently, without breaking any IPs up, then I were to implement something that we got from the research group at the University of Southern Denmark, and they had a lot of issues like helping us install stuff. Again, dependency help, but so we used a couple of days on that, and by experience we said absolutely we will implement stuff. But we took their methods and then took those parts that worked, as you said, we would do whatever necessary to put it into the product, and then threw things away that wasn't necessary. So we matured it by like doing some scoping.
All right, so you guys have been going up there for quite a long time, so we'll end this panel discussion with one last more open-ended question for all of you. I was really intrigued by a question that came up during Nicolai's talk. At the end, he talked about how industry takes a lot from academia it has recorded it themselves. So I'm wondering, you talked about this with Nicolai, so I want to hear from everyone. How do you think industry can go about giving back to academia?
Let me start from an academia point of view. We are already getting back all those things. There is so many elements that are maturing, and talking about my domain, walking robots. I mean, now people can just buy them, just as they were buying drones 10 years ago. If you would have to build yourself, mature yourself to do field robotics research about that, that's just no possibility. I think that's the way how we get a lot of stuff back from the industry, just because they're robustifying, they're maturing it, and then you can continue the next level research.
Yeah, and to that point, I'm seeing a general trend of like larger companies releasing like benchmarks or even real world like hardware that you can log into and actually execute policies. And I think that's really important because not everyone is obviously going to have the resources to implement this sort of thing. So hopefully we see more of that.
So what we started with is kind of an animal research community. So the idea behind was that people that have an animal that they can share and talk to each other about their experience of the robots. With a forum, with having exchange, etc. We can get access to quite a lot of software and so on. So pay more than what an end customer would get from outside. And also what we try to do is to bring back in terms of software. So we are maintaining some of the open source libraries in ROS, etc. And that's one point. We robustify the software, give it back, open source.
All right, well, thank you everyone, both panel members and everyone here. That was a very exciting discussion. Let's give our panel members a round of applause.